welcome to my channel. This is sixth problem in the series of top interview 150 problems. This problem says that we are given an array and a value of k. So we have to rotate the value, we have to rotate the elements till up to that value, and we also are given the direction whether we have to rotate it right or rotate it to the left. So in the problem, if you see here, we are given this array and the value of k is 3. It means that we have to shift three elements here from the right, and it is going to be in a way that all the elements are going to shift to the right, and then the elements at the right is going to shift in a cyclic manner. You see here, if like in the first case, if it is 3, then 7 is first shifted, and it is rest all elements are shifted to the right, and the last element came towards the first position. And similarly, the second element also shifted to the right, and it went to the initial position. Rest of the elements are being placed in accordingly. And then lastly, 4 shifted to the right. So in totality, 3 elements shifted to the right. Okay, and here you see we are given 2, so we can quickly say that 3 and 99 are going to shift, and then -1 and 100 are going to shift to the 2 positions right. Okay, so here, if we say that 3 elements, we have to shift 3 elements, it means that we have to uh, move 3 elements. Every array elements are moving towards 3 positions ahead. Okay, so let's quickly jump to the solution. In the solution, there are different ways of doing it, and we will first try the brute force approach, and then we will try to optimize it. Okay, so see here in the rotate array. So the very first intuition comes up, like here you see in the explanation itself. First, the last element is being picked, and then it is moving, and rest of elements are covering accordingly, like overlapping, like last second element overlapping the current position of 7, and then every element are moving, making a shift of 1, and then in the end the last element is placed at nums of 0. Now this resultant array is being processed, and then same process happened, that the last element is being picked, rest of elements are shifted towards right, and then the last element came to the first nums of 0. And then similarly it happened to for the 5. So this is the same approach we use in the brute force one. We pick. And one more thing is very very important. Here we see that the last element 3, see the last element, see the number of elements we have to shift, like to the right, k steps. If we have to always, in all of the approaches, we have to make sure that the value of k is not greater than the total length of the array. In every scenario, we are going to make a modulo of that. So I have written it in beforehand, the approaches, so that we can make the video quick. Yes, so but I'm going to explain each and every line, don't worry. Yes, so first we are rotating the array. Whatever I have explained, this is the same thing. We rotate the array one step at a time, and we do it for k times. Okay, so for each rotation, remove the last element, insert it at the beginning. This is the only thing we are going to do. Okay, so let's see how this works. And obviously, as I already mentioned, that this is a very very important point. Don't miss this point. This is a very very important point, and we have to always keep in mind that the value of k has to be modulo, and then only we have to make sure that this we don't forget this process. Okay, in every scenario we have to do this, so we have to move ahead with doing the same thing. Yes, so first, we are going to run this first loop with for k passes. Like for k number, for k times, we will run this loop. As I already mentioned, that you see we are given the k equals to 3, so this process happened 3 times. Here the k is 2, so this rotation process happened 2 times. Similarly, uh, this process is going to happen k times. Okay, and then we simply lifted the last element, we picked the last element, and then we overlapped the last second element. Like similarly, 6 came to at the seventh last position, and then 5 shifted to 1. Every element is shifted to 1 position ahead. So this is the same thing we have done, and then in the end we are placing the last element to the nums of 0. Let's quickly see how this works. Okay, So 0 1 2, please try to do this along with me. You can pick your copy and pen, and then like you can pick your notebook and pen and then start doing the same with me. So for the first time the 7 is being picked, so 7 is going to be get picked, and we are going to have the remaining array as 1 2 3 up to 6. Okay, and then 7 is going to come at the first position, and then we are going to process this resultant array in the second pass. The first loop has been over, and now what is going to be picked? Since we have 6 as the n minus 1 element, so 6 will get picked, and then as I explained, the 6 is going to come to the last, and we will be having this array as we will be having the array as one array as 6 7 and then 1 2 3 4 5. Now please try to do on your, please try by yourself that what we are going to pick. Just think for a second and then do. So we are going to pick here the last element, like this. We are going to pick the last element which is 5. Okay, so the last element is going to get picked. Okay, and then here we are, since the last element is already picked, so we will be left with 1 2 3 4 5. Okay, and also all the elements similarly 6 7 is also going to be there, so 6 7 1 2 3 4 all are going to shift one position ahead, and then 5 is going to, in the end 5 is going to take this position. So this is going to happen like 6 is going to the last position, and then 7 1 2 3 4 5 is going to get placed, and then 6 will come at the first position. And in this case 6 7 1 2 3 4 will shift to 1 1 1 1 1 place ahead, and then 5 will come to the this position. But you see what, then this is the good approach, right? But the problem here is that it is going to take, since we are every time we are going to increase the loop count, then the time complexity is going to increase. You have to keep this in mind, that whenever loop count increases, then the complexity also going to get increases. Time complexity is defined as n into k times. It means that k, so how do we compute the time complexity? Whenever there are, since there are two loops, so we are going to multiply this time complexity. If there would be two loops, then there would be n into there would be like more one element, like suppose one loop with n elements, then there would be n into k. So this is how we compute the time complexity. In this case we have k here, yeah, like just a minute. Okay, yeah, so we have k here, and we have k elements here, and then we have l elements here in this loop. So now we are computing the time complexity as n into k. Okay, so this is how we compute the time complexity, and we always use big O. And then we have not used any extra space, so it just big off one space complexity, there is no extra space. Now let's move on to a other better approach. This approach says that the idea here is to, we are going to copy, we are going to take one extra space. Okay, so in this case we are just simply taking the extra space, and then the extra space here, the extra space, like we will be creating a new array size, and then for each element we are going to place it. So here the indexing is important. Indexing says that we are going to place, so you see, if you notice, the resultant array was 5 6 7 and then 1 2 3 4. So every element here you see 1 2 3 4. So we had one here, earlier the output array, what it has, it is 5 6 7 and 1 2 3 4. So you see every element is shifting 3 positions ahead, right? So it is because we have k equals to 3. So can we say that we can every element is shifting at 1 plus k positions, right? So every element is shifting as 1 plus k position, sorry, I plus k position. The I is the current index, and plus k is the number of positions the element is moving towards, like shifting. So in this case we as I already told you that k, we have to always maintain this k equals to k modulo, and this will make sure that, suppose we are given 10 as a value of k, and we only have 7 indexes. So suppose we are given 10, sorry, I messed up, I'm totally new with these things. Yes, so here if you suppose we have 10, okay, we are given 10 as a value of k, then it is very important to do the modulo, because 10 is not a valid element to shift the elements towards right, okay. So in this case the modulo 10 modulo 7 would be 3, because obviously you will be knowing how to compute modulo, I expect to say. So right, so here it is important to compute the modulo, and then obviously this I plus k, so in this case as well we have computed the modulo for it, so that the index is not breaching its limit, area out of index bound kind of stuff. Okay, so let's see how this is being done. So we are quickly we are copying the elements at this position, okay, and keep in mind that initial few positions would be left. For every element we are going to place it in the rotated. So see how the rotated array is being filled. Okay, let's quickly see how do we do this. So in the first case we are going to have, let's see, let's quickly write the indexes. Okay, and now for 0, see, try to compute what it would come like. For 0, for 0th index we have 0 plus 3 modulo n. Okay, so 0 plus 3 modulo 7 is going to be 3, right? So we are going to place this nums of 0 at third position. So 0, 1, 2, 3. Here we are going to place the value. Okay, 1 is going to be placed here. And then now we have 0, 1 in the next iteration. We are quickly moving towards next iteration. Okay, so the value will, in the next iteration the value would be 1 plus 3 modulo 7. The value of k is fixed. Okay, so it would be 4 modulo 7, which is 4. Similarly we are going to compute the indexes up till 7. Okay, so nothing is going to change. So the value, initial 3 elements would be same, and then the value, the second value, nums of 1 is going to get placed here. Okay, now try to compute what is going to come next. The value is 2. The index value is 2 plus 3. Okay, it is going to be 5. So now you see initial 3 elements would be like this, and then it is going to be 5. Here we have second element at second index, and then element at second index is going to be 3, and what we are computing, 2 plus 3 modulo 7, which is 5. So at fifth index we have to place this 3. Let me know if I'm going fast. I'll try to turn myself a bit slow. So initially we have to maintain 3, and we have to fill out 4 elements only. Now you see now I have moved here, and now I will come here at fourth. Now the value of I is 4. So 4 plus 3 modulo 7. So what does it say? Sorry, I'm so sorry. Here we are only this is the fourth element, but the index is 3. So this is 3 plus 3, 6. 6 modulo 7 is going to be, my pen is not helping me with cutting. I'm so slow with this, sorry. So this is going to be 6. So now we have 1, 2, 3 elements left at here, and the 4 element which is at third index is going to come here. Now you see how we are going to compute next. I is going to move forward, and then we have 4 as the index and 3 as the k element. We have to do its modulo every time. We have to, don't try. We all know this. Yeah, we have to maintain this, all this like bracket. So plus is going to be computed first, then only modulo is going to get computed. Like we have to, this modulo has more, you know precedence than some. Okay, so yes, so 4 plus 3 is going to be 7. So 7 modulo 7, you all know. Please don't yeah, so compute and don't do any mistake here. So 7 modulo 7 is going to be 0, because how modulo is being computed, I'm just quickly telling you. 7 modulo 7, so 7 is going to get divided by 7, and then modulo is simply the remainder which comes. So 0 is the remainder here, and yeah, this is how modulo is being computed now. In the so at 0th position, it means that 5 is going to get placed at 0th position, and now we have only two elements left here. Okay, 1 2 3 4, let's keep it like that. And then I is going to move forward, and we have 5 plus 3 to compute the modulo with. We have 8 modulo 7. Okay, now you see we are going to divide 8 by 7. Okay, now we are going to divide, it is going to be like that. So remainder is 1, so modulo is going to modulo is computed as, sorry, 1, remainder is 1. So at first position we are going to do, and similarly we have one element left, 1 2 3 4, and at second position, like similarly we will compute, and then we will fill this out. Now in the resultant array, you see we have all the elements as expected as the output. We wanted the output as 5 6 7 and 1 2 3 4, right? And this is the same thing we have achieved in the rotated array. This all is going to happen in the copied array, and then array is going to get copied back at this final nums I, and then this is how the solution gets computed. But you see we have this extra space complexity that is being computed here. How do we compute the extra like space complexity? Space complexity is the extra space we needed to compute the solution. So here you see that we needed rotated array, right? And then rotated array has the rotated array is going to take space big O of n equally, because we are going to store n elements. So this is the extra space we are using. We cannot, like, interviewer is certainly not going to be happy with the extra space we are using, even when we are if there is any way to optimize the solution, the interviewer would want us to do that. So let's see how we are going to optimize this. The optimized solution is very easy. You all will, like, the wait will be worth it till now, and then you see that how we are going to compute it. Okay, yeah, so be very energetic and enthusiastic. Now we are going to be the compute the optimal solution. So see here, you see how, like, this is not the something like a dry run, but this is a simple, trick. Or you see how good you are at computing, like solving puzzles and all. So this is based on that. So you see, if this is the array, 1 2 3 4 5 6 7. What if we do like this? We rotate, we reverse the whole array, okay, like this, and then we reverse first k elements. So this is not going to be simply for this problem. This is a universal solution we can do. We simply rotate first, we simply reverse first k elements, and then in this case the rest of the elements is going to be the same. And then in the final version, we reverse last, like k plus 1, like this, sorry, I mean k, yeah, k elements first, k elements, and then k onwards to length of the array. So is this the solution we want? This is the same solution, exactly the solution we want, 5 6 7 and 1 2 3 4. So this is how we are going to do. This is very simple. Now I don't even need to compute, like, so show how this is being done. Reverse the entire array, reverse the first k elements, and then reverse the remaining n minus k elements. Okay, so like the indexing pair, let me write index pair, so yeah, like you keep in mind this in very prominent way, that 0 to n minus 1 we are going to reverse. Okay, and then 0 to k minus 1, this is up to k elements, because we take index by index always follows like -1 technique, right? Don't get confused here. And from k onwards up till n minus 1, so this is the technique we are going to reverse, and this is the only resultant array that is going to get placed here. So final array, final output is going to be this only. So this way we are going to, like, we are doing like maximum, there are three big O of n techniques we can do in the worst possible case, 3 into big O of n. So, and there is no extra space complexity. Let's quickly code this, and then you can after this solution, you guys might be like, this is what the weight, and you can also try doing like you can also please code along with me. I will suggest code along with me. Okay. Yes, so we are going to, first we are going to have this. Firstly, let's just quickly compute the length of the array. This is a very easy way. The optimal solution is interesting. So k modulo n. This is a very, this is a very important. I'm marking this as an important stuff. Don't forget this. Sorry. I'm marking is that something very important. Please don't forget this. Okay. Now, um, we had to first, let's write the reverse. How do we do reverse? Because we would be needing a reverse. And also, if you notice, I am not using any built-in method or any built-in functions for JavaScript solutions, so that everybody, if there is somebody coming from non JavaScript background, can also understand it. But this is not this is not my selfish way of attracting more people towards my videos. This is a way, you should always avoid doing using functions like built-in functions, because interviewer, this is not good for interview purpose. Like, you should always use the algorithms and ways. There is a very easy way to write the brute force approach. Here you can just do the pop and do like shift. Use pop and then do shift. You don't have to write even this loop. You can just use pop for popping up the last element and then do the shift. Just the 2 and 3 lines of code would be there, but still I suggested this form because I know the importance of this. Okay. Now, yes, so we will be sorry yes, so we will be having an array. We will be having the last index. We'll be having the we will be having the start index, and then we will be having the end index. Okay. And then we will be having like, simply we are going to reverse. Like in JavaScript we do like this, but you can pick, you can do on your own. How do we do the simply reversing? I mean, this is the way we do. Like, we can also do this using temporary variable. Like, we use the temporary variable and then we do the swapping. But this is the easy way to do the swapping in JavaScript, and this is a, like, you can also use temp variable and then do the swapping. Okay, and every time we do this, we will increment the start and decrement the end. So this is going to do the swapping for whole array. Sorry, and the most important thing I forgot, I have to put a loop here. Start, sorry, see, we will do this from since the beginning, and then we will be ending it. Like, we will be start from the loop. The loop would run like start should not cross the end. We have done enough of this thing in the two pointer approach. So if you haven't no, if you don't know how to use two pointer, please first see go behind and check how do we use the two pointer. So similarly, we are going to do this since up till start does not crosses the end, and then we are simply going to just to do the swapping. Once the swapping is like, this is simply the function we will be using for the reversing the array. Okay, so I have always some in my some shorts I have taught how to do the reverse. Like, it was some reverse vowels, I think. I did shorts. If you haven't seen that, please see, and you will get to know how to do the reverse. And then, so it was the way I wrote the indexes. You can quickly write it and in the problem will get solved. Like, sorry, I have to go down, and then I'll need to show you like this: 0 to n minus 1, then 0 to k minus 1, k to n minus 1. So nums from 0 to k minus 1. Okay. And then we have to reverse nums and then k to n minus 1. So this is how we do it. Let's try to run the. So this is accepted. I try to submit. You see it's submitted. Okay, and then let's quickly do how let's quickly see the notes. Like we do the reverse the entire array. We reverse the first k elements and then we reverse the n minus k elements of. I have already explained the time complexity is big of n. So try on your own. Keep learning, keep coding. Thank you for watching.